Alright, sorry for the last video interrupting. There's some technical difficulties, but let's pick up right where we left off. Alright, so remember, let's just focus on this problem. I like this problem because we have to think about a little bit more than just mid-segments and stuff. We get to think about sides, alright? But anyways, let's just focus on the mid-segments. Remember, multiply by 2. Alright, now I like to put parentheses right here. These parentheses, because it reminds me that I'm going to distribute the 2. So I'm going to do x plus 8 equals 4x minus 2. Alright, then once I distribute, I want to get all my x's on one side. I'm going to get 8 equals 2x minus 2. Then I want to get all my constants on one side. 10 equals 2x. And then divide both sides by 2. And x equals 5. Cool. Alright, what about y's? Those are sides, those aren't a mid-segment. Sorry, I just dropped my stylus on the screen. You probably heard a loud thump. Alright, remember, this is a midpoint, so this side's congruent to this side, so the y's you just set equal to each other. Nothing too special you have to do other than setting up the equation. And once we get this equation set up, we're in incredibly good shape, because then I'm going to distribute. I'm going to get 4y equals 6y minus 6. Again, don't forget to distribute to both sides. And this problem's a little quirky, but not too bad. We just got to deal with negatives a little bit. 4y minus 6y is negative 2y equals negative 6. And divide both sides by negative 2. Y equals 3. Alright. And then this problem right here. Ooh, this looks intense, a lot going on. But when we got a bunch of information, remember, just isolate stuff you know about. X's, mid-segments. Look, these two sides relate, so all I gotta do to focus on the x's is multiply by 2. So I'm gonna get 2 times x equals 5x minus 18. Subtract 5x from both sides. Negative 3x equals negative 18. Negative 3, and then x equals 6. Similarly, now let's focus on the z stuff. Alright. The z stuff, parallel, mid-segments. So remember, I gotta multiply by 2. Multiply the mid-segment by 2. So I'm gonna get 2 times z plus 8 equals 3z minus 10. And something you might have noticed is realize this is a 2. And my z's have a dash through it. It's probably a good idea to put dashes through your z's so you can differentiate between 2's and z's. Because some of you, probably like me, don't have the best handwriting in the world. It might be a little hard to differentiate between what's a 2 and what's a z. But nonetheless, distribute. Now I want to get all my z's on one side. 3z minus 2z is z. Get all my constants on one side, add 10 to each side, and z equals 18. Let me rewrite that. That was a little sloppy. Struggling. That's about as good as it'll get. Alright. Now, let's do some new stuff. Alright. So this is going to be kind of piggybacking off of yesterday, but now this is a mid-segment. We'll call this midpoint 1, m sub 1. M sub 2 is over here. M sub 3. Alright, so this is a mid-segment triangle. So if you remember from yesterday, we had a triangle, then we found the mid-segments. Now we have the mid-segments, and now we're going to find the original triangle. Alright, so let me think about something. Alright, we're just going to start diving in And we're going to determine the slope of this line right here. Let's focus on M1 to M2. Alright, so this slope right here is, let's write, let me think about this. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Alright, so let's say the slope of, and we'll just write M dash 2. So the slope from midpoint 1 to 2 was 4 over 6. Alright, now when we're determining slopes of things, we're not going to reduce. Don't reduce. Alright, which equals 2/3. Alright, now I just said don't reduce. Alright, let's go. I'm ready to go now. Alright, we have a slope of 4 over 6. Alright, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Alright, now remember, midsegments are parallel, so equal slopes. And so I'm going to go to midpoint 3 now and replicate that slope. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Boom. Alright, now I got to replicate that twice. Alright, because not only are these lines parallel, like right now, this is great. This blue line is parallel to this blue line. But this midsegment is not half the distance yet. It's not half the length yet. Alright, so instead of going up 4 over 6, I'm going to go down 4 over 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Alright. So now, these blue lines are parallel, and the midsegment's half the length. Again, this big line right here is part of my triangle. Alright, now what I'm going to do from here is just pick literally any other side. So let's do from slope of 1 to 3. 1, 2, 3, 4, 5, 6 over 1. Alright, so slope of midpoint 1 to 3 was up 6 over 1. So when you find the slope of a midsegment, you go to the opposite point. In this case, it's midpoint 2, and you go up 6. 1, 2, 3, 4, 5, 6 over 1. And then, so right now I'm in good shape. These orange lines are parallel, but I need to double the distance of this. So down 1, 2, 3, 4, 5, 6, left 1. All right, remember I just reversed the order, and now you can see my triangle forming, and this last part is the easiest. You just connect it. And look, I did such a good job, it went right through the midpoint. Alright, so that was kind of an intro. We're going to break it down more in these next videos.